friends, so after taking a numerical on Laplace transform, now we'll move ahead with another numerical based on definition of Laplace transform. So here I have changed the function, and now here we will learn how to find out value of that by using the definition of Laplace transform. So let's start. So here we have to prove that integration 0 to infinity e to the power minus t minus e to the power minus 3t whole upon t dt is equal to log of 3. So how to solve this question? So guys, the integration which is 0 to infinity clearly denotes that it is matching with the definition of Laplace transform, because as per the definition of Laplace transform we have integration 0 to infinity e to the power minus st into f of t dt, correct? So here I'll write down the definition and then we'll decide how to move ahead with the solution. So here I'll say now guys, as per the definition, integration 0 to infinity e to the power minus st f of t dt is Laplace of f of t. Now in our case we have integration 0 to infinity. Here we have e to the power minus t minus e to the power minus 3t upon t into dt. Now here if we compare this given question with the definition, then this function is f of t. It means this term, that is e to the power minus st, is missing. So I can say that it is nothing but e to the power 0, because e to the power 0 is 1. So it means I can say that the value of s is equal to 0. So guys, if I want to find out, or if I want to apply the definition of Laplace transform, then this term is nothing but Laplace transform of e to the power minus t minus e to the power minus 3t upon t, where s is equal to 0. So now I'm gonna solve this term, and I'm gonna find out the Laplace transform of this function, where I'll get answer in terms of s, and in that answer I'm gonna substitute s equal to 0. So let's start. So how to find out Laplace of this function? So guys, we have seen many properties before, and if you are not remembering it, then you have to go back and watch all my videos in series so that you will understand which property to be applied here. Now here in the denominator there is a term called as t, and it clearly shows that here we have to apply the division by t property. Now let's revise that property. So guys, here you can see that in division by t property we have Laplace of f of t upon t. So numerator is function of t and denominator is t, and its answer is given by integration s to infinity phi of s ds, where value of this function phi of s can be found out from the Laplace of f of t, and f of t is the numerator. So we have to find out Laplace of numerator and get phi of s. So guys, here my numerator is e to the power minus t minus e to the power minus 3t. So I'm going to find out Laplace of that, because that is going to be my phi of s. So here I'll say that Laplace of e to the power minus t minus e to the power minus 3t is equal to, so answer of this is 1 upon s plus 1 minus 1 upon s plus 3, and guys, I will call this as phi of s. Now by division by t property, this will become integration over s to infinity phi of s, that is 1 upon s plus 1 minus 1 upon s plus 3 ds. And guys, now I'm gonna find out integration of this, and after getting the answer I'll get Laplace of this function, and in that I'll put s equal to 0 to get the final answer. Now what is integration of this term? So integration of 1 upon s plus 1 is log mod s plus 1 and this is log mod s plus 3. So guys, here we will get log mod s plus 1 minus log mod s plus 3, and here the limit is from s to infinity. Now here I can apply the property that is log a minus log b, which is log of a upon b. So here I'll get log of now guys, let's substitute upper and lower limit. So upper limit is infinity. If I put infinity over here, I'll get infinity plus 1, infinity upon infinity. And guys, it is called as indeterminate form. You cannot get the answer. So here we have to prove that the value of the question or the value of this function is equal to log 3. It means it's a finite answer. So the question is how to get the finite answer from indeterminate form. So there are two ways. One is either apply L'Hopital's rule and get the finite value, or make the adjustment. So here guys, I am going to make the adjustment because that is the shortcut way. So what I'll do is, since my limit is infinity, I'll try to bring that infinity in the denominator, because I know that some number or some finite number upon infinity is equal to 0. So if I bring that infinity in the denominator, then I can get answer as 0. So guys, for that I'll bring this s in the denominator. So for that I'll divide numerator and denominator by s. So this will become log of s upon s1 plus this will become 1 upon s, and here s upon s1 plus 3 upon s, and this is from s to infinity. Now guys, here let's put upper limit and lower limit. First is infinity, so that will become log of, now see here guys, 1 by infinity is 0 by this rule, 3 by infinity is also 0, so 1 plus 0, 1 and 1, so log 1 I'll get, minus if I put s as s, then I'll get the same function, and if I simplify this I get back this function. So I'll write down that is log of s plus 1 upon s plus 3. Now guys, we all know that log of 1 is 0. So this will become negative log of s plus 1 upon s plus 3. And let's apply the property of log, that is, here I'll write down for you, that is negative log of a upon b is always equal to positive log of b upon a. So here we are getting log of 1 as 0, so this term will go, we will get negative log of this, and I'll make it positive by using this formula. So log of s plus 3 upon s plus 1. Now guys, here in this value I will put s equal to 0, because on the previous page we have seen that in our question, as per the definition of Laplace transform, the value of s equal to 0. So now I'll put s equal to 0. So here we will get 0 plus 3 3 and 0 plus 1 1, so 3 upon 1 is 3, so the answer is log of 3. And guys, if you will see the right hand side, then we got the answer. So I'm sure that you understood how I got the answer and how I proved that it is equal to log 3. So if you want to learn more videos on engineering mathematics, then guys, find me on ekeeda.com. Also, don't forget to share it with your friends, because they are also in the need of good teaching and good methodology to understand mathematics. Thank you very much.